Hello, and welcome to Backer Breaks It Down. This episode focuses on modeling with exponential functions. So change factors. So we know that when we go to write an exponential function formula, it looks like this: y equals a times b to the x power. Now, so far, our initial value, that a value, has been given to us. We have had to figure out what b is, and we have found b in a variety of ways. In the first lesson, we were given a table of values, and we were able to identify like the number you were multiplying by to obtain the next function value. And then we also worked with percent rates. Like we were given percent rates, and we know like we turn that percent rate into a decimal, and if it's growth, we go 1 plus r, and if it's decay, we go 1 minus r. Okay. But what about change factors that aren't one unit apart? Like say you're given a table of values or you're giving two ordered pairs. How do you find the value of b? And so we have a change factor formula that looks like this. Okay. So I have 2 points, x1, y1, and x2, y2, and I can find my change factor by calculating y2 divided by y1 raised to the power of 1 over x2 minus x1. Okay. But what is b? That is the question. Okay, so it all depends on what you're given. If you're given a table of values and those values are one unit apart, you can look and see what are you multiplying by. Okay, if it's not obvious, then you can use your change factor formula. Okay, and then if you're given a percent rate, turn it into a decimal. For growth, b is equal to 1 plus r, and for decay, b is equal to 1 minus r. So let's write some functions. Inflation means that a current dollar will buy less in the future. According to the U.S. Consumer Price Index, the inflation rate for 2005 was 4%. If you assume that the inflation increases somewhat and remains 4% per year for the next decade, you can calculate the cost of a currently priced $12 pizza for each year over the next 10 years. Let's see if t represents the cost of the pizza t years after 2005. Write an exponential function that models the pizza cost. So c of t equals, right? So we start with our initial value. The initial value of the pizza, or the initial cost, was $12. The inflation rate is 4%, right? And inflation is a growth situation. 4% as a decimal would be 0.04. And so if I go 1 plus that, I get 1.04 as my base to the t power. Okay. You have just purchased a new car for $22,000. Much to your dismay, you have just learned that the value of your car will depreciate by 30% per year. Let V of t represent the automobile's value after t years. Determine an exponential function to model this. So we can say V of t is equal to the initial value of $22,000. And this is a decay function. So my rate is 30%. If I turn that into a decimal, I'm looking at 0.30. And when it comes to what is b, b is equal to 1 minus r. So if I go 1 minus 0.30, I get 0.70, and that's my b value. And then don't forget your exponent. A news article titled "Study Indicates Volunteerism Rises Among Collegians" made the claim that the number of college students volunteering grew more than 20%, from 2.7 million to 3.3 million between 2002 and 2005. Okay. So in this problem, we are given data points. So we know in 2002, there were 2.7 million volunteers. And we know that in 2005, there were 3.3 million volunteers. So to find the annual growth factor, I'm going to use my change factor formula. So B is equal to Y2, so 3.3, divided by Y1, 2.7, raised to the power of 1 over, and I would do this math in my head. So X2 is 2005 minus 2002, that's 3. So I'm going to calculate this, right? And on my calculator, you should definitely put all fractions in parentheses. So in parentheses, type in 3.3 over 2.7, hit that caret button, and then in parentheses, put your 1/3. The calculator figures this out properly, and that's what we'll do. And so we end up with a change factor of 1.069. What is the annual percent growth rate? Well, remember, in order to get the rate, I have to go base minus 1 times 100%. So if I were to take the 1.069 times or minus 1 multiplied by 100%, we end up with 6.9%. Find an exponential model for the number of college volunteers. So we could use V for volunteers is equal to the initial amount, which was 2.7, and then our B value, 1.069, and we can use T for years, right? And so here we have it, an exponential function for the number of volunteers. But in this problem, we had to use our change factor formula because we were working with two data values. So there you have it. What is B? That is the question, and it's all based on what you've been given. So if you've been given a table of values and those X values are 1 unit apart, you can look and see what are you multiplying by, and that's your B value. If you're given a table of values or two data values, you can use the change factor formula, where B is equal to Y2 divided by Y1 raised to the power of 1 over X2 minus X1. And finally, if you're given a percent rate, turn that percent rate into a decimal. And if it's growth, B is equal to 1 plus R. And if it's decay, B is equal to 1 minus R. And that is how Backer breaks it down.